Hello and welcome back to another chemistry video. So today we're going to be talking about isotopes and average atomic mass. So isotopes are the same atom, so the same atom or element, with different numbers of neutrons. So that's really important. So they're the same element, which means same number of protons. So we can see one proton, one proton, one proton, because all of these are isotopes of hydrogen. But one thing that they all have different is the number of neutrons. So this is what most people think of when you think of hydrogen. This is hydrogen 1. Deuterium down here is H with a 2. And tritium is 3. So remember that top number here is the atomic mass. So all of these are hydrogen. They all behave like hydrogen, but some of them, see, deuterium is twice as heavy as what they call protium, or what most people just refer to as hydrogen. And this is 3 times as heavy. So that has some interesting properties. And one of them you'll hear about probably at some point is heavy water. So we know water, H2O, behaves how we expect it to, but there is something called D2O. So D2O is heavy water. And that's just because it has the same properties, just the molecules are a little bit heavier. So that's useful because we can tag things with heavy water. If there's water in something, we can replace it with heavy water and then track to see that. And we can also use that to measure kinetics to see if water is involved in a particular reaction. You could drink heavy water, although I don't recommend drinking a lot of it because it would eventually kill you because it would slow down chemical reactions. And T2O creatively is super heavy water. So isotopes have those several uses that I just talked about, and they also sometimes can be radioactive. So you've heard about radioactive isotopes of probably uranium or plutonium. Uranium-238 will decay into uranium, I think, 235, and it releases energy that way. So there are several things that isotopes are used for, but for right now, the important thing that you'll have to do with them is calculating average atomic mass. So we're going to go down here to an example, and you've probably seen on the periodic table, we'll see if I can draw this. So we have our little square, and it's number 1, and we have hydrogen. And then at the bottom, it'll say 1.007. And you're thinking, why is it 1.007 if hydrogen, what we think of as hydrogen, is just 1? It should be 1.00. So that's because there are small amounts of deuterium and tritium present in nature. So they take that into account when they make this number to give an accurate reflection of what you'll get in an actual mole of hydrogens. So if you had a mole of hydrogen atoms, some of them would be deuterium, some of them would be tritium, and your mass for the mole of hydrogen wouldn't be exactly 1 gram, it would be 1.007. So now we ask, how do we calculate that? So I've included an example here of carbon. So we know carbon-12 is what we think of when we think of carbon. Carbon-13, however, also exists. There's also a carbon-14, which is carbon dating. That's how they do carbon dating. But we're not going to talk about that one right now because there's not enough of it to really be concerned. So we see here that this number right here is what's called the relative abundance. So it's the relative abundance. That's about how much of carbon-12 there is in relation to carbon-13 in the real world. So we see that 99% of carbon is carbon-12 and 1% is carbon-13. So we can make those into decimals. So 99% is 0.99 and 1% is 0.01. So then to find our average atomic mass, which is the number that we're concerned about for the periodic table, what we do is we take the mass of carbon-12 12, times its relative abundance, so 0.99, and we add that to carbon 13 times its relative abundance, and we can see from our work here that the answer comes out to 12.01. So that's the number you'll see on the periodic table. This is exactly what a weighted average is. So if you've ever had a course where your professor said exams are worth 50% of the grade, quizzes are worth 20% of the grade, and homework and projects are worth 30% of the grade, when you're going through and calculating all that, this is the calculation you did. It's exactly the same here, and all it depends on is the number of our neutrons. So these red dots, we can see on the bottom, there's an extra one. And that is a very brief overview of isotopes, their uses, as well as how to calculate average atomic mass.